All right, now for question 13. Little correction here. Please remember this is 3.5 newtons. And we want to know the force of gravity on the box. Please remember when we see the word force of gravity, that simply means the weight. And so I'm going to do weight equals the inertia of the object times the acceleration due to gravity. And so I will take 2 kilograms times 9.81 meters per second squared, and I end up getting 19.62, which is approximately 20 newtons of force. By the way, just to kind of make this clear, this is what the free body diagram of this object should look like. And so when we ask what is the force of kinetic friction acting on the box, we have Fa going to the right, Fk going to the left. Those need to balance, so that should be 3.5 newtons as well. Now, for this next problem, I'm going to actually go ahead and solve it now. It says, a chandelier is suspended from 2 wires hanging from the ceiling, each making an angle, and we want to know the tension in each of the wires. So we begin using the recipe that I passed out in class. So step 1, a free body diagram. We've got tension, tension, and we have the weight pointing down. Now, since we know we have forces at an angle, this is step 1. Step 2, let's split this tension into components. So I have Tx is going to be T horizontally 25, that's cosine. Ty is going to be T at the sine of 25. And we actually go ahead and work those out. This is going to end up actually working out to 0.91 T. And similarly, for the sine of 25, it works out to 0.42 times T. So, now let me redraw the free body diagram with our relabeled forces. So, now our free body diagram is going to look like we have Ty from each of the tensions, and also Tx from each of the tensions. And we have the weight going downwards. Now, step 3 in the recipe says set up the equations in x. So we're going to have Tx minus Tx equals 0. Or if you prefer, Tx on the right equals Tx on the left. And this is actually a useless formula for us. We can't do anything with it, and if that happens on the exam, don't panic, just use the next formula, which is the Ty formula. So we have Ty from one going up, and then from the other going up. And those balance the weight. And we have Ty plus Ty equals W. Now here, we actually can go ahead and calculate the weight, because we're going to need that. So W equals 36 kilograms, its mass, times 9.8, and that's going to give us 353 newtons. And notice that's actually one of the choices here, and we do throw you off by doing that, so you've got to be careful, because that's actually not the answer to the problem. To get the answer to the problem, we go back to equation 4. We're going to put in 2 times, now Ty is 0.42 T equals 353. And when we finally solve for T, we're going to end up getting 418 newtons of force in each one of the wires. So this wire has 418 newtons, and this wire has 418 newtons. And that's the answer to the question.